Okay, we're looking at the week 31 mini test, question 1. So we're on moments and equilibrium. So we've got a uniform rod, so that means the center, the mass is going to be working through the center. So that's 60 newtons is going to be halfway along the rod. We're told it's 14 meters long, but then also we can see that 20 plus 11 is 14, hopefully. And the support is 3 meters from A. Again, that's on the diagram, and it's held in a horizontal position by this force here. So it's in equilibrium, and we're asked to work out the magnitude of F. So that's going to involve taking moments. I can't just resolve forces vertically, because to know F, I'd need to know R and vice versa. So that's what we're going to be able to use for part B. So I'm going to take moments, and the most sensible point to take moments about is at the support, because if I take moments here, I don't need to know the reaction force. So that's what I'm going to find for part B. So if I label on all the forces, so we've got the reaction force, we've got F that we're trying to find, and we've got the 60 newtons. So I'm going to take moments about R. Oh, I'll move that up. So to take moments about R, I need the distances. So I know that that's 3 meters. Now I know that the whole rod is 14 meters long, and it's a uniform rod. So the 60 newtons is going to be working 7 meters from the end. So that bit, which is what I want, the distance from R, is going to be 4 meters. So that means that makes that total distance between A and the center 7 meters. Okay, so if I'm taking moments about R, this force here, pulling down on the left-hand side, is going to be causing an anti-clockwise moment, and that's going to be the magnitude of the force F times the distance. And if it's in equilibrium, that must equal the clockwise moment, which is going to be due to that force there. So the clockwise moment is going to be that force of 60 newtons, and that's a distance of 4 meters from R. Okay, so 3 times F is 60 times 4. So it's right over here so you can see it. So F is 80 newtons. Okay, so that's part A. Then for part B, you were asked to work out the reaction. So now, I mean, I could get that by taking moments about a different point, but that would be making it harder, because now I can just resolve vertically. So I know that that force is 80 newtons, and obviously that's working downwards. So if I think about just resolving the forces vertically, the total downward force is 80 newtons plus 60 newtons. R is the only upward force, so R must equal those two added together. Yeah, because it's not moving up or down, so it must be in equilibrium vertically. Okay, job done.